Okay, class, so today I'm the lecturer, Big Money TH. I'm here with my assistant,
Coop job.
and we have Danny writing stuff down. So let's just jump right into this. So, an electric cell generally consists of two different metals. It says metals that are separated by an electrolytic solution or paste. And you can think of a salt bridge from chemistry.
Can you elaborate on that, Mr. TH?
Well, if you think of the paste as a salt bridge from chem, that's all you need to think of. Now, between the two metals, an anode and a cathode, exists a potential difference that can convert chemical energy into electrical energy. A battery is a device consisting of one or more cells, like from living environment cells.
It's not from a living environment.
It's got the same name, but it's made of metal.
You're wrong.
And salt bridge.
Two different metals.
Two different metals. An anode and a cathode. There are two types of cells, and from here, my good assistant, Coop Job Krunick, will take over. We're right here, by the way.
So there's a primary cell, and primary cells cannot be recharged because during its lifetime, its lifetime is irreversible chemical reaction takes place, and this cell is disposable. There's a secondary cell designed to be recharged, can reverse the chemical reactions in the cells. Example, car batteries, lithium-ion batteries.
Those are found where? Where are they especially important?
The auto store.
And the smart board.
Like
Cell phones.
cell phones and
Computers,
Tablets, laptops.
cars, golf carts.
Why are you looking at me? You're talking to Micah. Oh yeah.
It's your part, Mr. Sedano.
Okay, we need to go quick. We're at 3 minutes. So,
Now,
I just got kicked out.
we all know that batteries hold charge for a certain amount of time.
Yeah.
So, if you ever wondered what's the difference between a AA, a AAA, a D battery, a C battery, they all have 1.5 volts across them based on the metal setup that our previous colleague was talking about. So the difference between the batteries, you notice, is their size. Okay, and what the size matters about is not so much the voltage. Okay, it's the amount of charge that it can hold. So we talked about the charged property called charge capacity. And that's how much charge that can flow before the cell stops working, and the cell stops working again because the chemical reaction stops. So the key unit for the amount of charge is the amp hour. If you ever buy those portable battery packs that you can plug your phones into, you will see one of the key parameters that you buy for is how many amp hours it can hold. Okay, so what we want to ask is what exactly is an amp hour? Well, if you look at it carefully, an amp hour, 1 ampere is current, an hour is time. Current times time is nothing more than our old friend charge. So we can ask ourselves how many coulombs of charge is an amp hour? Well, we just convert that to an amp second, right? So if charge is current times time, and that's units of amps, and this is supposed to be seconds, so coulomb is an amp second, then we can simply do amp hours to get the number of coulombs. Okay, so 1 amp is 1 amp, an hour is 3,600 seconds. So we can see that 1 amp hour is 3,600 amp seconds, which is 3,600 coulombs. So you essentially have 3,600 lightning bolts worth of charge stored in amp hour.
That's a lot of charge.
That is a lot of charge. Now, in those portable battery packs, I don't know off the top of my head how many amp hours they are, but I believe they are more than 1 amp hour. They might be 20 or 30 amp hours. Now, we talked about in class what happens when you connect more than one battery to another.
Oh, it's my
All right.
turn.
T-Money is going to step up and finish this part.
Okay. So what happens when more than one battery is connected to another? Well, this happens. When it's in a series, all the EMFs just add up. It's that simple. Just they add up. And then when positive to negative for that one. Sorry. When connected positive to positive or negative to negative, the EMFs subtract. It's whack. I don't know what she's drawing.
So our assistant is drawing a schematic of 2 batteries. Notice that the 2 long parallel lines, okay, we've connected them positive to positive.
Yeah.
So one side is 10 volts, the other side is 6 volts. So they're not working together to make 16 volts. They're working against each other so that the net potential across the circuit is negative 4 volts. Negative just indicating a direction, in this case, to the right. That's the way the current is going to flow. Now, why on earth would we ever connect 2 voltage sources in opposition to one another?
Well, in case you were wondering, the answer to the question is this is how a secondary cell is recharged. Bet you didn't know that, did you? Huh? When connected in parallel, the EMFs do not add, so that's a lot like when they're connected, but not. They don't add together. What actually happens is a bit more complicated. If the EMFs are the same, then the effective EMF is the same as either battery. If different, roughly speaking, the effective EMF is average the EMF.
That's not something we're going to have to worry about too much, but understand when you hook batteries in parallel, you don't get more voltage. In fact, what you get is less internal resistance, which allows you to draw a lot more amperage for a brief period of time, and that has some uses for that. What you want to know is, though, generally you connect batteries in series to add or subtract.
Now look at this graph right here. It looks wild, doesn't it? Yeah, it does. So,
Why is that, Mr. TH?
what was that?
Why is that?
Well, because right here, right there, see that?
Mm-hmm.
And it goes down.
What is that?
That's the starting
What's that mean?
volts.
Ah.
Come on, it's how much the battery has initially.
You mean EMF?
Yeah. And then you see it goes woo, and it kind of like levels out. But then right here it's like, whoa, and it just goes down. That's because you see it levels out right here, right about there, and then it just drops fast. So batteries, they just die really fast, like really
When
fast.
they die quickly, but they last a while.
Yeah, but they last a while, like from here to here, it's lasting, and then it just dies. So it loses its initial value quickly, but then it's fairly stable. So you say fairly because it's just still going down right about there. I don't know what Danny's drawing. Oh, it's a lightning bolt. It's Harry Potter. I don't know.
It's the Flash.
It's the Flash. I don't know. Okay, this is period 8 to 9 physics class. I'm Big Money TH.
I'm Coop Kroon.
Danny Snyder.
Signing
Spider.
out. Peace
And-
out. Man, this is. Oh, we got Nick here.
Dr. Nick
Tristan's back
Hartnett.
there on his phone.
All right.
Hey, Tristan.
So I've just got myself back into the room after they locked me out. Finish these problems as best you can. Actually work on them in
problems.
class. All right, have a great day.